Okay, so Aaron Bergmeyer, Don Wynn, and I, we've been working on trying to create test program its entirety using Origen. So one of the things we noticed was, well, we need to have a concept of AT hardware, what channel, what instrument that's being used per pin, by the pin, and and power supply. And so I wrote some stuff to allow us to import the tester config of the tester you're using as well as the channel map you're using. Um, so the way that this works, and this is part of the Origin tester gem, is you go to the tester you're using. This is UltraFlex only. You go to the tester you're using and grab the current config from the iChicks folder, and you use that to load it in. Okay, and so the command itself is import tester config, and the way that it is, in my case, you can put this anywhere really. I have this in my SOC top. You have the path, and then you give it a name. We also have the concept of, well, we may have multiple inserts. Each insert may have the different tester config. And so in this case, I'm putting three different inserts, which means three different tester config. In my case, I have a final test, a wafer test, and I have a final test ED config, which is slightly different as well. And but for the ease of knowing which one we're using, I create a concept of a default tester config. And same thing goes for channel map as well. So the very first one that gets loaded is going to be your default tester config. The first channel map you loaded your default channel map. You can obviously change it, but for looking things up, that's the whole purpose. And so again, same thing for import channel map. You grab the channel map file that you would use in your iChip program normally, and again, you give it a name and you give it the physical address for it. And so let me just get out now. I put a trap in my code, so just to let it easier because we fry things like colors so easier to read. So not sure why. Okay. Anyway, so let me quote my sheet real quick. That's what I talked about. So first thing first is I'll show channel map. So in this case, I'm just taking the channel map that from iGXL and load the entire content into Origin. You can see I have size. Well, that was one of the names that hang on, let me get that real quick. So if I do .heat, you can see I have three sets of channel map I loaded, right? And so if I do that, you can see I have size 0, and if I keep going, and I have all the pins with a pin name, site number, channel, etc. All that is in there, okay? And let's see. And obviously, you can do things like
like hash and hash. Is that a hash?
Yeah, exactly.
Why are you using that?
There's really no reason to rhyme. I mean, I just pick it because I don't know any better. So, but anyway, the point is, I just want a way to be able to get all the content in there, and because I was trying to figure out a way to be able to add on to have as many channel map, as many tester config as I could, and it seems like a hash of of struct seems to be the best way for me to be able to access it without overwriting it over and over again. So that's how I picked it. So, but like I said, you can do this, and you can do things like size, etc. All the information of type and that kind of stuff is all there. So, and then like I was saying, there's a default channel map which is set to the very first one loaded, which in this case is final test by 2 channel map that I called it. I also wrote some methods to be able to use it, and so I can do things like tester, get tester channel. So in this case, asleep is one of my pins. I give it size 0, and it'll tell me, oh, it's slot 17, channel 7, for example. I can obviously change it to size 1. I can change it to size 4, things like that. Everything can, depends on what it is. Same thing goes for,
What do you have used for?
we'll get to that. Okay. So, same thing goes, same thing goes for tester config. I just take the content of the current config and load it in. The entire content is in there. So you got a slot, you got an instrument, you have the ID prompt, um, the exact content that you have in the current config. At first, I didn't know what we would do with the ID prompt, but as it turns out, it's actually very useful. I'll get to that in a little bit too. So, um, so that's the and same thing. You could do things like set the config, which one it is, which slot I can do and that told me it's a VSM supply, for example. Um, and same concept, I have a default tester config, which in this case is FT final test, so I can change it to whatever I want as well. Um, yeah, exactly. So, but you can change it on the fly if you want. So, and also I wrote a couple of methods to do. I can do a get instrument slot. You give the tester config. And let's say you just want to figure out what slot VSM is not interested. Let's do hex VS, for example, because I have two of them. You tell me that I have three of them, or I can do XSD view, I'll take to have a bunch of them. Okay, so like that. Or I can do tester dot get tester let's see, instrument, and I'll give it and it'll tell me it's VSM, or I can do say 2020. That's one of them. Okay, 23 or whatever. So that kind of stuff. Now, so that's good and all that, but we also then so to answer Joe's question, right? What do we use this for? Well, we're writing interface code to populate test instance sheet. Okay, and so when we're doing like parametric tests, for example, we're saying, well, okay, well in digital network we have some system, for example, well, power supply is a good example. So in our typical system, we have VSM, hex VS, we have HDVS. We also have sometimes have what UBS 256. And so knowing which supply is what type of instrument is used is very important. And then if you go from probe to final test, we have a mixture of instruments. And so knowing the content is important. So now we'll be able to pull that and say, if we're using HexDS uses thing, otherwise uses
Yeah.
other thing type thing,
Okay,
right?
so you let it decide as it goes
Exactly.
what the appropriate instance or,
Exactly.
to build this flow you're asking for.
Yeah.
Okay.
So now we got there. Now we're saying, well, okay, so now we know what type of instrument we're using. Well, maybe we need more information about the instrument itself. Okay. And so I added a lot of, basically I opened up IGXL help and start taking all the content, some of the content and dump it into Origen, right? So, and so, so for example, I just use VSM and, it's, um, it's kind of hard to say what to put in there. And so in this case, VSM's a supply, so I dump a bunch of stuff like 4C iron, source overload, current, yada yada yada, and I just stick everything there. May not be the prettiest form, but at least we have the content in there. We can go query it. We can do like let's see, we can do like I don't know, source, boat, max, right? You know, because it itself was a range, right? So we can start doing things like forceful I, um, and then you can pick which one you want, that kind of stuff. So that helps. Same thing goes for say on the basically what I figure out that is we really just want to know a little bit about supplies. We also need to know a little bit about the PPMU on the pin electronic side. Everything else, I don't know if we have the need yet, so I haven't put anything in there. So, and so for the digital channel side, I've done some stuff for PPNU. So, for example, you can see this is the Utah, Ultra Clean 1600, and you can see the same thing. We got the, fourth eye, all the typical stuff. You can do math and all that stuff if you want, right? So that's kind of useful. Um, so now we got that. So then was talking to Stephen about this, and we were trying to see if we can, if you can see everything I'm doing is $ tester. Would be nice to be tied it to the dot side as well. And so wrote some more code to do this. And so now putting it all together. So for example, I let me hang on. So I was doing that with the tester. Sorry, hang on. I think I did this earlier, right? So this guy, for example, I knew it's slot 17 dot channel one, right? And so I want to get that same exact information there. So on the depth side, and it should give me that same exact information, right? So we tie all together, so everything's there. And obviously, you can do on this. You can also do like ECMU, and you can do like again, you can do fourth eye. Everything's tied together there. Um, so then, we can just go through, we can store through the list of pins and say, hey, what is this? What can we want to use and that type of stuff. On the power supply side, it's the same exact thing, right? So in this case, I have a all pin group. I can do the same thing, and this like that. I can do things like you know, DDD. I can do supply all the same information. I can do things code all the information is there. So then we can start grabbing this for our test instance purpose. So okay, that's the general gist of what I have done. Last thing I want to show is the concept of the default channel map and how things work. One of the things that so for example, most of our low board nowadays or probe card nowadays are multi-site, right? Um, in most cases, you really don't have a different instrument per site. But just in case there is, I want to give people a flexibility. So in my case, my default channel map is a by two channel map. And when I was looking up the channel map, it only print one site, right? Because I didn't want to print out too many sites to get confusing, right? So by default, I'm loading the site 0 of it, right? But I can do site 1 if I want. And so I was the same, uh, I don't do this a lot, so I have a cheat sheet of all the things I do. So may have lost it, but oh yeah, something else. Let me go back there. So, yeah. On the tester side, you can see I obviously put side 0 and side 1, everything works. But on the depth side, um, on the on the that one I can just do like side 1, and it will give me a thing for me. Obviously, this is not going to show you, so I'll do channel, I guess. Right. So, or if I didn't do that, it will give you the site 0. Well, obviously, I can obviously do a site 0 of it, and it's the same exact information as the default. Okay. So now again, now I'm going to show the concept of having default, right? So I think I showed. So right now, my default channel map is final test by 2, and my tester config um, is default tester config is final test. Um, I happen to have two different channel maps. I have multiple channel maps. I load 3 channel maps. Um, one channel map works. The channel maps only work on certain config. They can't work on a different config, right? But I have the same exact package pins, just different channel map, right? And so in this case, I was going to show this guy right here. But I happen to have 2 different projects a different project with the same supply name called proc NTR. And so on this default channel map and this config, it's on HDDS by 2, HDDS. And then now I'm going to go and change my default channel map to SD by 4. And I'm going to go change my default tester config to SDTZ. Obviously, you have to know which config goes with which channel map, right? Nobody's going to know that. In my case, I happen to know that. So I change that to that. And I'm going to change this AT hard, check that guy again. So now you can see it's now loading the different thing for us. Okay. So that's the concept of having, because our concept is for the digital network, it's very common for us to have one test program that we have multiple channel mapping in, right? So when we validate, we can just load a probe channel map or the final test channel map and then validate on that specific tester. And so be able to have multiple channel map and tester config loaded, we can generate one giant program for everything.
So you showed us before where on the AC hardware object, you
Mhm.
also could have options, right?
Yeah.
Or
That was
here
for
today
that-
with Pen Group, but could I have also told it I wanted it to give me that answer in line
Yeah.
with that like AC hardware, and then I would hold it in that equals something, and I have it. So is the only way to get the answer is set the default and then ask it, or can I inline?
I mean,
in the query.
the default setting of channel map and tester config is set when you import the channel map and tester config.
Right. Well, I mean, you change the default to get a new answer to the
Yeah.
query.
Yeah.
What I'm asking is there any way to do that in line in the query? Give me this answer for this.
You could on the tester side,
Okay,
right?
Because, right. And I saw you do that on.
Yeah, exactly. On the tester side, on the dev side, I didn't do that.
Okay.
So.
We would just do it by changing the default.
Yeah, exactly. Okay. Yeah. The way that I was thinking was more of a if I'm generating test instance, for example, and we will go through and say, hey, did something change between the tester config? Do I need to create a new test, right? So in our case, for our trip test, for example, we have to create a pro version trip test and final test version trip test, that kind of stuff.
But you're going to let the tool decide that.
Exactly. So we'll write code to cycle through and then check it. Let's see what else I was going to show.
So any pin groups that you have in Origen is going to be the master of the pin group.
Yep. Well, no, actually, so the stuff I'm not all the import stuff I'm doing. I'm just putting a hash somewhere. Today I don't have any thing to check against the pins I loaded in Origen. Okay, and so there may be a mismatch complete. In fact, there is because the FT54 channel map is a completely different project. I just grabbed it to show this purpose, right? The die size is like 5 times different, by the way. So that's why that project can do by 4, but my other project can only do by 2 because it's a completely different project, right? So that power supply is like the only thing that was identical. I was able to show it. So.
The longer term, you're going to do something where you're going to compare the channel map against the Origen pins.
Yeah, exactly. Oh, so the other thing I want to show that I just remember now is I was saying that when I was loading tester config. I was saying at first I didn't know if using something in the ID prom was important or not. Well, it turns out it is important because I'm not sure if you guys are aware or not, but there are certain serial number of power supply. Depending on it is, it gives you a different accuracy level.
Yeah, I don't the plus.
Exactly. And so if you notice, when we load it in, like I said, I just grabbed the exact content current config and I just grabbed the exact name and put it in a hash. I didn't do anything to it, right? And so if I go to if I do like on the tester side, if I do whatever, it if I do tester and I do earlier I had like the get instrument call that kind of stuff, right? It's just gonna take query the hash and dump everything out as is, right? But on the depth side, now I have the information of the channel map and the tester config, and so I can see okay, slot 13 I'm using VSM, and I can go look at the ID prompt and say the ID prompt is a variety of the high accuracy, then I can do something different about it. Okay, and so that's exactly what we did. So if I scroll up earlier, if you notice the instrument, you see this guy right here. Um, Down here, by the way, VHDVS is Teradyne's name for UPS 256, right? So, if you notice, this is VHDVS, but when I query this guy right here, notice the name's a lot longer. It's actually VHDVS HC plus by 2, okay? By 2 means it's merged 2, okay? HC is the high current, plus is the uh, high accuracy. Okay, so I created all that and dump it out, and so we have the content for it. Okay.
And how did it know it was in high current, high accuracy?
Well, so I'll talk
Is
through
that in your
that.
channel map?
I'll talk through that, right? So the by two, we know by two by the channel map we had to merge, right? So we know that information. The high current, that's also in the channel map.
Okay.
So I query that. The plus is I'm querying the ID prompt, and it's not ID prompt, I dump it in there. And so so if we go back to, let's see, actually have it a teach sheet already, I think. Um, yeah, I do. So we have a teach. So for example, if you look at VSM, and if I look at, you see the I range is like 5 of them, right? But if I do VSM by 2, which is a merge to, often I have more now, because I'd add a hashes in there. To give you guys an idea of,
Now, is your vision that your gut code or your gut model will pick the appropriate range? I mean, is it your code that's going to pick the appropriate range?
no, my code just provided the information. So Don is in the process of writing some interface code to grab this information and make the determination. So,
It's not.
but this is a this is a base needed for that information to make that decision. So by the way, just to give you an idea, this is no comment, but these are all the instruments just on the power supply that I did. VSM by 2, by 4, HexVS by 2, by 4, by 6, HexVS plus by 2, by 4, by 6, HDVS by 2. You can see, I had all that content in there just so that everybody can use it. There's obviously some other supplies that we don't use that I guess you guys use DC30, for example. I don't know. We may. Yeah. So I didn't put that in because we don't use it. So I mean, if somebody wants it, we can probably put it in, right? Put it in the same format, that kind of stuff. So. That's called iJigsaw help. So. I only knew of two. I only knew of the 2 things, so I put the 2 things in there. And so in our case, I don't know if I put it in case. So I wrote a couple. So there's a HexVS. So I wrote a code check if HexVS plus or not, and that's just looking for the ID prompt. There's also for UVS 256. Also there's a plus and not. Those are the only 2 I'm aware of. So and also for UPS 256, there's a high current option or not. So I wrote code for that. I'm not aware of any, like I say, if there's more, obviously we can add to it, that kind of stuff. So anyway, that's all I have. So.